In this problem, we have 1959 IMO problem 1. We want to prove that the fraction 21n plus 4 is divided by 14n plus 3 is irreducible for every natural number n. So, now you might think that this problem, since it's an IMO problem, is probably very challenging. Well, not exactly, because it depends on how you approach this problem. Because you don't want to just, plug and chug the values for n inside this fraction. I just want to prove that it's irreducible for every natural number n. So instead, the way to approach this problem is by proof by contradiction. Now, in proof by contradiction, we assume the opposite of what the question is asking. So we can assume that 21n plus 4 divided by 14n plus 3 is a reducible fraction. Now, since it's reducible, we can let the greatest common factor be p. So let the GCD be p. Then we'll have, since it's the greatest common divisor of 21n plus 4 and 14n plus 3, we know that p must be a factor of 21n plus 4 and 42n and 14n plus 3. So thus, we can apply congruence modulo to get 21n plus 4 is congruent to 0 mod p, where 0 here is basically the remainder when 21n plus 4 is divided by p. And then we can multiply both sides by 2. 42n plus 8 is congruent to 0 mod p. And we can subtract the first equation. We can subtract the second equation from the first equation. So then we'll get 1 congruent to 0 mod p. Now this is clearly absurd because p is impossible for 1 to be congruent to 0 mod p, because that would mean that 1 divided by p is congruent to 0. So this contradicts and proves that our initial assumption was incorrect. So hence we'll get that 21n plus 4 divided by 14n plus 3 is irreducible. So that is how you prove this problem by proof by contradiction.